Thank you very much, Chris. I appreciate it. Always great to see you guys. Thank you, Lee, too, for helping out with this. So it's a month ago we did part 1. Can you guys hear me and see me, Chris? Everything good still?
Yep, got you. Yep, got the first slide up.
So quick, the first few slides, a little reminder. So I'll let you guys read on this. And then who we are. Most of you probably are aware of who AcoustiTECH is. This is not the core what we want to talk about. So I'll focus obviously on the solutions and also more importantly where the problems can come from. So if there's a couple little things you can take home with you, that's going to make my day. We're going to basically, like I said, in order to understand some of the things I'll talk about, I'll just remind you, for those of you that were there a month ago, it's going to act as a reminder. For those of you that were not, I'll go quick on this, and if ever you're looking for some information, additional information from part 1, I'm sure Chris and Lee can help out with that. We're going to focus basically where acoustic problems, complaints come from. So as ironically as this sound, ultimately, obviously, I'm not going to go too much into the solutions, but we're certainly going to identify in our experience. So for 20 years plus of doing this, where do we feel the fails can come from? So it's not going to be about structural engineering. It's going to be a lot more onto the design and expectations and such. So I'll go through a little bit what my observations and our observations are over the past little while. And of course, how to avoid them. So I'll use examples as much as I possibly can within the time we've got. And then we'll quickly go to recap and takeaways, questions, question and answers. Okay. This is something I showed a month ago. It just, if you read more on the bottom, so I won't go through it, but no one's going to be surprised knowing that ultimately a lot more people are working from home. The acoustic complaints and lawsuits are skyrocketing over the past couple of years for obvious reasons. So obviously it's more on top of mind than ever before. So there's obviously stats that's not coming from us. This is coming from different organizations and different places. But ultimately, it's a direct link to why are we dealing with this even more than ever before. So the first part of this, where the problems, complaints come from, underestimating expectations. So I'm going to touch on that for a minute because it's actually huge. So all of you are aware that there's 2 types of noises, airborne and impact. So quick reminder, STC required by code in Canada is 50. The ASTC, which stands for apparent sound transmission, is 47. And the recommended minimum STC is 55. We use the term a lot more than ever before, the term comfort, when it comes to sound versus requirement. Because ultimately what that means is people nowadays, especially over the past few years, we found out, and some people found out the hard way, that people are expecting a lot more than what the code actually requires. So obviously on the STC, it is required to be at 50, but that's quite low, really, as far as what the comfort level is. So Mr. and Mrs. Smith, as I said a month ago, they don't really know what the code says, nor do they care. So what we see on a day in, day out basis, whether it's existing building or new construction, is people are shooting for higher than 55. So the new 50 to some extent, or the recommended 55 to some extent, as far as our observations are concerned, should be a bare minimum what we're trying to shoot for. Quick reminder, airborne is everything to do with a sound that is not in contact physically with the structure or originates from a physical contact. So it's side to side, top to bottom. So music, radio, pets, anything like that that's not in contact with the structure is airborne. And we should probably shoot for over 55 because that's what people really expect. Okay. As far as the impact, different animal completely. The IIC required, there's none in Canada. Therefore, there's no apparent IIC required by code, but the recommended minimum is still 55. So the building code recognizes that it should be about the same number, but it's not required by code. Ironically enough, 80 to 90% of all complaints we see come from the impact transfer. And Chris, your example with the water bottle could be expanded to moving furniture, to walking around, to dropping objects, opening doors. Anything in contact with the structure is creating nightmares out there for all kinds of structures. So we see it day in, day out. And ultimately, the level of comfort people are looking for, there's nothing to justify it be lower than the one on the airborne. Meaning, we should most likely shoot for 55 and higher, and too often we end up much lower than that. What that means is we often see a discrepancy, because it's not in the code, between the STC and the IIC. So the number of times we see a building shooting on the airborne side, whether it's floor ceiling assembly or wall to wall, 55 plus, but then we see the IIC in the 40s is weekly, which creates obviously a major issue, because people are not complaining about the sound they hear as far as television or noises or voices, but they do hear their neighbors walk or moving furniture or kids playing. So ultimately, what I am saying is, again, people don't know what the code requires or even recommends, but as far as we're concerned, a 55 plus should probably be what we're shooting for, because that's what consumers, condo owners, renters, or even going to a hotel, that's what they expect more than ever before. Okay. The other thing that obviously is related to issues would be misunderstanding and application of the principles. So last month, we covered a pretty basic acoustic principles: mass, resilience and decoupling, void treatment, sealing and flanking. So right now I'm addressing this to the new construction, people involved in new construction, but also retrofit. A lot of times when we're building, I'll give you an example on a light wood frame building. A light wood frame building, all of a sudden, because of cost and everything else, we start reducing the weight load of that particular building, but we don't realize that it will have a direct impact on how noisy and how much vibration is going to go through that particular building. So a lot of times we make design-oriented decisions without necessarily understanding what downside is going to be. And we see that a lot. So that's a good example. The mass is, do we have mass? Example, if a strata has a wood frame building and there's no topping, there's no mass, well, you cannot expect out of the gate the same performance, despite the underlayment you'll have to ask for. Your building is still not going to be at the same place than another building that may have a topping or that may be made of concrete. So understanding that mass, resilience and decoupling, which is directly linked to how much vibration is making it through the structure, how much void treatment. So ultimately, if it is a light wood frame with a ceiling, how much insulation is in there, ceiling openings, put lights, air vents, ductings, all these kinds of things. How treated is it, whether it's new construction, and what we're going to do in a design stage, but also on the existing building, what was done when it was built, and flanking. Those are principles, and once we understand them and we're able to assess a particular building, whether we're working on it for new or it's already there, it goes a huge ways to understand where we're starting and where we can go. So Chris, I come across that, my team comes across that on a regular basis, where we don't even talk products, we talk principles. Here's why you're running into issues. It's because your building is very light. So then we need to apply the right recipes in order to apply the principle of mass, or everything's touching. So if everything's touching, well, and it's hard surface flooring, well, then nothing is stopping the vibration. So those are examples of how understanding the principles can become an immediate solution for architects and builders and stratas and contractors to actually avoid issues down the road. Because from experience, it's a lot harder to fix something or an acoustic issue once the building's up than when it's at the design stage, or even when you're redesigning, I guess, with a renovation. Okay. So again, if you want more information on these with videos, which we showed a month ago, be more than happy to show that to you. Please.
Just to give you a sense of what happened in that file with those two videos, there's nothing that they can do to retrofit or change that building. No one's going to rip out the flooring, take apart the structure and put it back together. It's not going to happen. So we just came back with a bunch of advice. Cover the high traffic areas with a 60% area rugs. was one, have a meeting between the two owners so that they understand that one is not just a hostile, nasty person who's trying to keep them up all night.
Yep.
Convey the time schedules. Like one person was going to bed at a certain time, which was, you know, an active time for the person above. And you find that you can get people to work together, provided they understand what the problem is. No one wants to upset anybody. So it was just, that was an interesting case. And I think we got them over there. They realized there's really nothing they could do. They just had to learn to live together.
Chris, that's phenomenal points. I mean, ultimately, especially on an existing building, I mean, you're dealing with perceptions, you're dealing with humans. People hear things differently. So there's no doubt, that's why I referred at the beginning to expectations, but also you're correct. There's in some cases, it's going to be hard to apply some of these principles depending on what the situation is, but at least understanding where it's failing or understanding where the issue can come from, at least it's pointing us in the right direction and we're not fixing the wrong problem. And more importantly, we're not spending money on things that are going to be completely irrelevant. So this is a great example and good add-ons on that.
The last thing we advised the property manager to do was to go back to the owner in level 3. The other suite was the top floor. Anybody who buys below is buyer beware. Advise them, you bought this suite, you should have known that this could become an issue. Therefore, it becomes your responsibility within reason. So anyway,
absolutely. And again, transparency, you know, out of the gate, and not making or telling something to somebody that they want to hear. Is no doubt about that. Yeah. Part 3 would be quite important, especially related to the flooring industry, Chris. And I've heard you 1,000 times advocate for this. Lack of knowledge, and again, I'm not saying that in a bad way. Lack of knowledge, misleading information is certainly extremely present in the flooring industry. As an example to this, I'm well aware that most of you are aware of what I'm about to tell you, but I'll give you a little bit more data when it comes to this. But to some extent, assuming that a concrete slab application, for example, will shoot an IIC impact insulation class of 72 is ludicrous. It actually is. There's no such thing as an assembly unless it would be built up in a ceiling. So I'll touch on that in a minute, but there's a lot of misunderstanding on how this actually works and how an acoustic test is performed and what we can actually expect. So as an example, we see a lot of high numbers being thrown out there right now in the flooring industry. And even though a lot of people are aware that those numbers aren't achievable, we don't always know where to go with it and where it's coming from. So first thing I want to mention is you can never associate a rating to a product. I probably have said these exact words 1,000 times, if not 2,000 times in my career. It is extremely important to understand that when you're doing a test, you're testing an assembly, you're not testing a product. So if somebody comes to you, or even worse, if somebody shops in a store and says, I need an underlayment, gives me a 72, well, we're already in the wrong, assuming that the underlay itself is going to give any kind of rating. So it will contribute, but we need to know what it was tested with and where is it going to actually contribute to a better performance. Because I've also seen adding products into an assembly that did not bring anything. I've even seen it make it worse. So to some extent, we have to know what the assembly, what the building structure is, what the context of that particular assembly and application and building is. So one of the things that we do is, or that we should do is, hey, somebody walks into a store, I'm looking for data. Okay, what is your building structure? Do you know the drawings? Do you know how it was built? And if we don't, it'd be probably interesting to talk to the condo board and kind of gather that information. Because if we don't understand to some extent the building context, it's impossible to figure out where we're going to end up, what's the building capable of, and what the solutions and what the proper solutions are. So, and I'll touch on that in a minute and give you some examples. So when it comes to comparing apples to apples, because we deal with that a lot, you all deal with that a lot, is, okay, there's a number on a piece of paper, or there's a promise of a certain performance. Okay, let's now look into the fine prints. Was that particular product within that particular assembly, was it tested in a lab? Was it tested in the field? There's a huge difference between the two. Being tested in a lab is a controlled environment, no different than, and it's very applicable to today with the price of fuel. It's like me telling you that my car consumes a certain amount of, does a certain amount of mileage. But if I'm giving you a number on the highway and I'm on 100 kilometers an hour on cruise control, it will not consume the same thing that if I'm driving in the city. So that's why the car industry started introducing two numbers a while back, where you see consumption in the city, stop and go, and you see consumption on the highway. It's obviously probably still not what the numbers you're going to get, because it was done to some extent on rollers in a warehouse, but at least you get two numbers that you can compare depending on what your application is. So lab and field will not give you the same rating, even though it'd be the same product. So sometimes it can be 4 or 5 IIC or STC less on a field tested in the field product or assembly than in a lab, because it's not a perfect environment. Sealing and no sealing. Sealing in different applications, example on a concrete slab, can add anywhere between 10 to 14 points. So if you take a 72 IIC, you put it into, and it was tested in a lab, and you put it in the field, then ultimately maybe you're sitting at 68. I'll use that as an example. Then if there's no suspended sealing in your application, but you find out that the test was done with the sealing, it is not impossible that all of a sudden you're at 58 or 54. I've seen as low as 72 publicized, and in real life it shoots 53, 54. So again, looking into the fine prints of what each of the components within an assembly is going to contribute to, and understanding the context in which that particular data is provided. And last but not least, the source of the information. Where is it coming from? Is it coming from a lab? Is it coming from a typical manufacturer? Is it coming from independent third-party acoustic engineer company? And on top of that, where was it tested and with what? So we could talk about this, Chris, all day. I know we've had multiple conversations. You've been advocating for this so many times before. So I don't know if you wanted to add anything.
No, I think that's pretty clear.
Okay. Beautiful. So again, I can even tell you, we'll touch on that in a minute. The choice of the floor covering could be even completely drastically different, even if it's 2 laminates or 2 vinyls or 2 engineers. So there's even differences within the products themselves that contribute to a certain data. And I'll touch on that in a bit. Role played by the structure. Again, we're into the design, understanding what the building structure is capable of. Because it's not true that because you're on concrete, you're good to go. The high frequency on concrete are a lot more problematic than people think. So Chris, if you would have done the water bottle drop example, and this would have happened in a concrete slab application, you would have been surprised how noisy it is in the unit below. It's actually very prone to transferring the high frequency, which dropping a water bottle, high heels, or moving furniture is quite prone to. So concrete structures are not as bulletproof as people make it sound. There's certainly some areas that we got to be careful with it. And steel, wood frame, and mass timber, we'll touch on that in a minute.
Yeah, I remember being in a concrete home one time when the people were renovating upstairs, and they were using like a Kango type jackhammer to get the old flooring out. That thing may as well have been right beside my ear. It was absolutely transferred 100% into the space below.
100%.
It's interesting that you make that observation. That concrete's thought of as being a great way to sort of kill noise, but it's not necessarily.
You're 100% right, Chris. And again, we're coming, it's coming from thousands of tests and seeing it is, and again, if you look at the slide, the concrete towers, the concrete slabs are going to be very efficient for low frequency. So you won't hear it, but low frequency and then high frequency would be your knuckles on the table versus your fist. So low frequency, very efficient, no doubt about it, because it's heavy. Where the high frequency, the jackhammers or anything that's more like of a distinct kind of sound or something quite hard on the slab itself, or even if it's a glue down vinyl, whatever it may be, it's very distinct and it travels through the whole building a lot easier than we think. So you're correct. It's not as, like I said, it's not as bulletproof as we think. And one of the biggest difference between concrete structures and other structures is there's usually no ceiling. What that means is you find yourself having a floor, a hard surface floor, possibly an underlayment if there's one, and a concrete slab. You have one shot at applying the principle of decoupling in that application.
Yeah.
You can only do it once. So you better choose the right thing that's going to compensate for that lack of performance on high frequency. So again, when we get to the underlayment, I'll touch on that.
I was literally on the end of the tuning fork.
What's that?
I was literally on the end of the tuning fork with that Kango.
100%.
Yeah, well, same sort of thing, but TV. Some guy had his TV on at 3 o'clock in the morning, and we tried to find out who it was, and it was no one on our floor. It must have been a floor below. We just stopped looking in the end. He just couldn't tell.
So again, problems will happen in every kind of buildings, no doubt. Similar to flank, like again, steel structures, flanking, steel will vibrate. A bell at church isn't made of wood, it's made of steel. It vibrates so you can hear it from a distance. This is no different than this. And when you're dealing with steel structures, it will vibrate. We need to mitigate that vibration. We need to control it somehow. Good news is there's obviously solutions to that at the design stage, whether it's in the ceiling, underneath the floor. So there's assemblies that are designed to do that. Okay. Lightwood frame, a lot of components to play with, which means we can do some great things. But a lightwood frame, by definition, because it's lighter, then all of a sudden you're running out of mass. Decoupling is even more of an issue. Ultimately, because it's porous, if you create vibration and energy, it's going to travel all throughout the building. So wood frame buildings tend to have a bad rep. But if we actually play with the components, apply the principle, manage expectations, we can do great things. But only if we do that. If not, we're stuck in the 40s, and then complaints and lawsuits are up to wazoo. So we see it day in, day out. That's even more true on existing buildings that were built 20, 30 years ago, because some of the technology were not even applied then. Imagine when you have a wood frame building, 4-story or 3-story, and there's absolutely no mass. The floor is directly over top the plywood. Well, then you're in trouble out of the gate. You haven't even started, because ultimately that vibration is going to have a party making it to the unit below. Okay.
Andre, we're at the
Andre,
we're at the 1:30 mark.
Perfect. Thank you. So mass timber, for those of you that are aware of what mass timber is, obviously the big thick slabs, it's getting extremely popular. But again, a concrete tower, imagine that made of wood. If there's usually no ceiling because people want to see the wood underneath, well, that means you better do a really good job at decoupling on top, because the slab of wood is lighter than a slab of concrete, which means the principles are playing against you. So there are solutions to that at the design stage, but we need to look at it at the design stage. If we don't, we're going to find out the hard way that building is going to be vibrating and flanking like no tomorrow. And then obviously it's directly linked to issues, complaints, lawsuits. And we've heard of them. We've worked with people that had issues that will never want to go through that process again. Okay?
Andre, just on the topic of products, when you mentioned that, it's interesting. My mind sort of visualized, what would you put over that wood substrate to kill the noise or decouple the noise when you got the people down below want an exposed ceiling because they want to look at the beautiful wood. I remember back in the day when we did a few of the floors in the wall center, and they, on that job, specified a 1/2 inch thick rubber product, which was ribbed halfway through. So quarter inch of it was ribbed, like corrugated almost.
Yeah.
And we had no idea whether this was actually going to work. It was really expensive. But what do you recommend as a product that might kill sound in a wood frame structure with that scenario? So
understanding the NFCA format, I'll be cautious with my answer. Put it this way, Chris. What we need to do, there are solutions and there are products. We have products in our lineups. So again, it's not only often like an underlay, they're structural systems that exist that are designed to compensate for that mass, and in the meantime, creating that decoupling. So we have systems for lightwood frame, for mass timber, that are designed to do exactly that. But the only way you bring a product to market in these applications is understanding how that structure is going to work and where are the weakest points are going to be. So for example, mass timber, we have a system that's designed super light, that's designed to be in combination with layers of plywood. That's going to bring you to a heck of a good place, but it wouldn't be an underlay that I would put on a concrete tower, because it's not the same sound. We're not prone to transferring the same vibration and frequencies. So without going into details, Chris, in our lineup, we assess all these situations, figure out, is it the IIC that's problematic? Is it the STC? And within that, is it the low frequency, the high frequency? Is it the decoupling? Is it the mass that we're trying to solve? And then we bring some solutions and options to the market to whomever's designing it.
No pun intended, but what you're saying speaks very loudly right now. Is don't just specify it because it's got a high IIC number on it.
Well, Chris, I'll tell you one thing. And again, I'll use this as an example, as a guinea pig. If somebody would ask me right now, what is your best structural system or what's your best underlay? I have absolutely no idea what the answer would be until I understand what building and what you're trying to do. Exactly. So I don't know if that answers enlightens you. The problem right now is too many people answer that question very quickly. So if you walk at Buildex or surfaces and you ask questions to some of the booths and ask them, hey, how's your underlay performing? They'll throw a bunch of numbers at you. That's the last thing we'll do. Because you don't know if it's concrete, you don't know if it's mass timber, you don't know if it's lightwood frame, you don't know if there's a topping. So ultimately, the right thing at the right place, my man.
And homeowners don't have the benefits of design professionals doing this research on their behalf. They just go into the floor shop and they get the best IIC they can. And
they do not know what questions to ask. They don't know what to look into. So as professionals, you've heard me say this before, as professionals, it's our job to guide people with the best of our abilities, because people coming into the stores or coming to us, they don't have an idea what the STC and IIC is. They don't know what the number means. They don't know any of it. So to some extent, we need to be able to guide them to what's going to actually work within their application in order to create that comfort level that they deserve. Okay. Floor coverings, I'll touch on it not quickly, but I'll go through a little bit what our observations over the years are. So we kind of, and thanks to Frederick, my colleague, put this together a while back. So to some extent, a little bit of again, observations and facts about different floor coverings related to sound, of course. So obviously carpet, you're all aware, best for IIC, for the impact. And why that is? Simple, because decoupling and resilience, something soft is going to absorb the vibration a lot better and faster than something that's hard. That's how it works. The science dictates that. So that's why when we were 30 years ago dealing with condos on concrete towers with carpets, we weren't running into issues. The day we started to introduce hard surface flooring, all hell broke loose. And why is that? Because the science of acoustics says the IIC is going to travel through dense materials faster than through soft ones. That's the way it works. So if somebody says, I got carpet tile in the hallways, great. If your mass is there, your void treatment is there, ceiling is all covered, you're going to be in good shape versus something else. So ultimately, carpet is the best for IIC. STC, ironically, Chris, you might find that interesting. I worked on a hotel a while back and they were going to put carpet directly over top plywood on a wood frame. There was going to be no mass. What I told them is, okay, your carpet's going to do a good job on IIC, but only on the high frequency, not on the low. So when somebody heavy foot is going to walk on that carpet, it's going to make the plywood bend and you're going to hear that stumping noise, even if it's carpet. And the STC is going to be problematic because the mass is related to stopping voices in television and radio and such. So it's not because you got carpet that you're out of the woods. We need to understand where it's going to perform and where it won't perform. That's why we combine different technologies and different materials within an assembly. Okay. Engineered hardwood, floated or glued down. Depending on the treatment, floated technically will perform a little bit better, but that's not a rule that we go with. It depends again on the slab. It depends on a lot of the parameters. Easy to decouple in most cases because it's quite of a stable floor covering. Mechanically stable also because it's usually pretty thick. So ultimately, even though it'd be a thinner engineered, ultimately you're not too worried about movement, at least not as much as other things.
And it's not supposed to be, and it's not supposed to be fixed to the substrate if it's floating, right? So you've decoupled it by
or double glued down. So again, Chris, if you take an engineered hardwood, you glue it down to the concrete, the performance is going to be in the 40s. It's not going to be great at all because nothing is stopping that vibration from traveling through the assembly. So we need to decouple it. We need to decouple it, at least if you want to be at a certain place. If you're not too worried about it, okay. But if it's a residential multifamily application, absolutely, it requires the right treatment underneath.
So beware adhesives that come with IIC STC ratings, and just know what you're getting into. That's not to say that they don't bring something to the table. You just got to understand what it is.
Again, here's how I'm going to answer this. Is it plausible that you'll do a single glue down and you'll be at 55? It's plausible. The big question we ask is it going to happen 10 times out of 10? Chances are it won't. And two, let's look at the fine prints. Ultimately, a single glue down will never outperform a double glue down unless all the stars are aligned and you're in a situation where the slab is extremely efficient, the floor is extremely efficient, but we don't have control over that in most cases. So I would say to be cautious. I'm not saying to advise against it, not here to say that, but I would say to be very cautious because we've seen some nightmares happening with that, where it did not shoot nearly where the data or the piece of paper said it would, and then ultimately it put people in a heck of a spot. Okay. Laminates, again, floated. The good news with laminates is you have no choice but to use an underlay. You cannot just use it flat on the substrate unless it would be a little bit of a backing. But ultimately, the good news is you have no choice. So may as well figure out what's going to perform the best for you. And there is a gigantic range of performance between underlays. Huge, especially depending on the application and what building structure you're on.
Let's just qualify what you said there. Laminate must be put over an underlay, but it also must be floated over that underlay. Whereas engineered hardwood, you can glue it to the underlay and glue the underlay to the substrate.
Yep.
So laminate brings that benefit that you can only put it in one way.
For sure. And then vinyl planks is obviously a new kid on the block over the past, let's call it 10 years. Huge growth in the market. We see it a lot. I got nothing against vinyl planks other than, again, be aware, be cautious. Vinyl planks are by definition, usually from experience, don't quote me, usually a little bit harder and denser than other floor coverings except ceramic, which means if it's denser, the science says it's going to travel faster, vibration will travel faster. So again, you've got to set the table, Chris. I didn't tell you to do that. You took that upon yourself. But vinyl flooring, SPCs, WPCs of this world, great advantages, great features, no doubt about it. But at the end of the day, acoustically speaking, they come with its share of let's look into this because it's harder. It requires a treatment that's going to be compatible when it comes to sound because it will tend to transfer a lot more than other floor coverings. But the second section to that is mechanical stability. Because it's usually a thinner product, there's limitations to what treatment you can have underneath of it. So we often find ourselves in a position where somebody wants great acoustics, but because the floor is a certain thickness, let's call it 2.5 mil, we don't want to go under it because it's creating too much movement. So now people have to make a decision. Are you more into the 2.5 mil or 2 mil vinyl? That's even more true if it's glued down. Or are you looking for acoustics? In often case, a decision has to be made, but you usually don't end up with both. So very often, and I'm not afraid saying this, Chris, very often people have to make a decision because you don't have the best of both worlds. Unless you're sitting on, let's call it a 4 or 5 mil thick product over top a proper treatment, you can achieve great things. but the thinner products, the thinner flooring can be problematic because they're harder to treat.
It is a great point you make. SPC flooring is, you get that back attached foam that's a 1.5 millimeters thick, and you cannot put SPC, or you should not put it over another underlay to bring forth an IIC or an STC rating, or to up the ante. Because if you do, you just create too much movement and the joints give way.
Well, there's maybe I want to add something, and again, not to get into outside of format, but we have done hundreds of thousands of square feet, if not millions, of combined, but with a backing plus something we have. But at the end of the day, the thickness and the overall mechanical stability is looked at out of the gate. So we don't just say, yeah, sure, use a 3.5 mil and it's good to go. So that's why I am referring to making sure that acoustics and mechanical stability is married together. They don't fight each other, because often case the mechanical fights acoustics and vice versa.
Let me just qualify that's a good point you make, but let me qualify what I just said, because if the underlay, let's say you bring it to the table of cork, which is pretty rigid, non-compressive, it does compress, it's considered resilient, but that would be something that it's worth going back to the SPC manufacturer and saying, would you be okay with this product over top of cork? If you're putting it over a squishy foam underlay, you're asking for problems.
Well, and again, you're correct. I mean, but again, the performance and the irony of what you're saying, again, that's something if people are interested, and even yourself, Chris, to have a more technical conversation on your points, I'd be more than happy to have it. Ironically enough, again, if you look at the performance of a specific underlay, if, for example, you use a cork underlay underneath a cork-backed vinyl, chances are you're not going to improve your acoustics at all. So there'd be no reason to do that. But if you introduce a technology that will bring higher performance on the high frequency that the floor on its own with a backing will not provide, and we're able to make sure that mechanical stability is there, we can do unbelievable things. And we have done that multiple times. So the doors are not closed. We just need to do our homework and see where people want to be. So we've seen on concrete slabs in the high 60s with no ceiling of exactly what I've just referred to.
Yeah.
Okay. So there are ways for that.
Question,
Andre.
Yeah.
Kim Anderson in Winnipeg. Just a quick one. Now you're testing specifically on the entire the sandwich, everything that's in between.
Yes.
But if a designer, let's say, who's getting befuddled by all these IIC figures from suppliers selling it to them, I think we talked about this in the first part, was ASTM 2179, which has got to do with sound impact reduction. If you wanted to compare product A against product B, that's probably about the best you're going to do, and you're going to find out they're probably pretty much the same. Because say on resilient, 2 millimeter resilient, you're going to get a sound impact reduction of, I think it's 5 decibels. On a say a 5 millimeter click product with an acoustical back, the sound impact reduction's around 20 decibels. So now you have a comparative product to product, not IIC, not the whole sandwich, just component to component. Is that?
You're referring to the delta to some extent, correct, Kim?
100%.
Yeah. I'd love to, because you interviewed last time and I enjoyed your comments and whatnot, and I enjoyed it now too. I'd love to have a conversation on the side with you on that front, because the delta, there's certainly some great things about it, but there's certainly some little angles to it that we need to pay attention to. But you're correct. I mean, it's a good indicator.
Because when the architect is picking the product, they'll phone you or they'll send you an email to state, well, this one's got IIC 70 and yours has only got 57. So end of argument, right? So, well, no, that's not. If you want to do comparison, do the impact sound reduction. Don't do the IIC, because you don't know how the sandwich was built. They got 2 layers of drywall underneath. You know, what have they got? So
you're 100% right. The ISR goes a long ways. And again, for the platform and whatnot, like there's so many terms, Kim. There's like, even we're now dealing with the low frequency testing, the high frequency testing, depending on the application. So there's a lot more science behind this that than just calling an underlayment company and they won't even know what the ISR is. So I 100% agree with you. There are ways to do apples and compare things from each other and trying to cut through all the BS that can be around it.
Yeah,
Andre,
it's
we're at 45 minutes. Sorry, guys.
Perfect. No, I'm just about to wrap up this slide. So thank you
We
for
are
your comments, Kim.
Let's just go back into that a little bit. We're working on language to explain delta as simply as possible. It is a bit of a misleading. It's such an easy solution. It can be somewhat misleading because there are so many different scenarios. But we're looking to get language onto the website that I mentioned earlier so that you can refer to that. But we're going to have to get agreement from several different parties so that we get the right verbiage put up. So that's coming.
Perfect. Thanks, Chris. Take a couple minutes. So ceramic, again, very, very hard, extremely difficult to sound insulate. So once again, using the right product underneath, there is a way to soundproof tile more than we think, but it's never going to compare to some extent unless you build it up to a different floor covering simply because it's much harder. Underlayment, we kind of touched on that. I'm not going to go into this. So ultimately using the right thing at the right place. I'm telling you, it goes a long ways. In some cases, using a certain technology will outperform another one, and then the exact opposite on a different assembly. So to some extent, if we understand the principles, where the weaknesses are. So for example, if we work on a building where the high frequency is more problematic, we'll cover the high frequency with the right underlay. If it is a low frequency that we're going to run into, there's no point of covering that with the underlay. We're going to cover the low frequency with the right underlay. So understanding and dealing with people that understand this and are able to navigate through this, you'd be surprised for the same amount of money how much more performance you can get simply by using the right thing. Okay. Installation, and I'll finish on this, Chris. A couple of little tips. Obviously, it goes without saying before installation, proper surface prep and site conditions. I mean, the NFCA, you guys are extremely involved on that front. We cannot stress enough how important it is. Decoupling the floor covering from the structure goes a long ways. You can decouple the floor all you want, but if the floor is touching the wall or we're kind of bridging some of the components, it can obviously be devastating to the overall performance. Decoupling furniture from floor covering, huge. So when you're moving a chair, it's not hard on hard. It's ultimately like a pad underneath. It's going to go a long ways. Percentage of surface covered by area rug. You touched on that a little bit earlier, Chris. Not everybody wants to do that, but to some extent, if you are in a position where nobody's changing the ceiling or changing the floor, well, you're kind of running out of options. So yeah, covering some of the traffic areas with rug is certainly going to muffle a lot of the vibration that can be created. No doubt about it. Avoid ceramic tile in common or high traffic areas. Ceramic tile conducts more than anything else. No questions. So ultimately that is something that we would recommend depending on the situation. Using professional installers. Obviously the education with the installers, we're all about it. To make sure again that they understand what we're trying to do all together, and everybody kind of gets together on the design stage, and then follow manufacturer's recommendation to some extent would be would touch obviously on the mechanical and everything else. So those are some tips on that front.
I think it's a great list. You just made me think again that I'd underline in the specs, if this is possible for any spec writers out there, the importance of leaving that expansion gap around the perimeter for the flooring. The manufacturer requires it anyway. If you don't, and you leave the floor tight to the wall and there's expansion, all that floor experiences is stress at the joints. Not only does it start to creak and squeak, but you're now going to have that tuning fork scenario where noise gets transferred from one floor down to the floor below. So how do you underline installers leave expansion gaps? It's we see it all the time in inspections. It's the number one thing that is causing problems out there is no expansion gaps. They don't respect it.
And not only that, Chris, I can even tell you in the ceiling, like short circuiting we work in the ceiling, right? So short circuiting a resilient channel or a suspension system. I mean, anytime we short circuit anything, anytime we get something to touch with something else when it shouldn't touch, you're going to jeopardize. And we see crazy differences between something that's installed properly and in an application when it's installed properly. It's unbelievable. You can see 5, 6, 7, 8, 9, 10 IIC difference between the two, even though it's the same products used in the assembly. It's extremely important.
Yeah.
I'll finish on this and we'll go to Q&A. Requirement versus expectations. People expect more than what the code asks for. So it's our responsibility to decide where we stand on this. We've made our choices. People can make theirs. Ratings equals an assembly, not a product. Follow the principles, read the fine prints, the right product at the right place, talk to the right people to get information, the right information. Proper installation is a must. Better acoustics equals less frustration. Any questions or concerns or comments? Chris, I might let you go into, I don't know if chat, you see it all, but I don't know if there's a question in the chat box. Do you see it?
Oops. Let's just kill that.
No,
Too
that was
many
something
questions
else.
this time. That must mean that you've done a great job educating us on this topic, André.
Well, thank you. Thank you for the opportunity. Thank you all. If any of you, basically, here's my contact. If any of you want to get more information, you're interested, you're working on something, whatever goes without saying, that we'd love to hear about it. We'd love to help you out. We'd love to collaborate with you. And then obviously you can reach out to Chris and Lee too if you want. But ultimately, yeah, if there's any question, anything we can help with, let us know.
And anyone else who's caught up in this acoustical industry, if you supply product, if you know, whatever you do, and you have an opinion on something, your perspective, there's always 3 or 4 different ways to look at everything in this world. So please reach out, share, and we'll be very happy to bring you into the mix. So with that